HDO and MDO plywood. HDO and MDO plywood combine the properties of exterior type plywood and plywood with superior wearability of overlaid surfaces. HDO, high density overlay plywood, is manufactured with a thermosetting resin, impregnated fiber surface that is bonded under heat and pressure to both sides of the panel. It is more rugged than MDO and is suited for such punishing applications as concrete forming. The resin overlay requires no additional finish and resists abrasions, moisture penetration, and damage from common chemicals and solvents. Like HDO, MDO, medium density overlay, is an exterior type of panel manufactured with 100% waterproof adhesive. It accepts paint readily and is suited for structural siding, exterior color, accents, panels, soffits, and other applications. Where long-lasting paint or coating performance is required, MDO panels should be used outside should be edge sealed as soon as possible. 1 or 2 coats of high-quality exterior house paint primer formulated for wood should be used. Edges are more easily sealed while panels are in a stack. Next section, hardwood and plywood grades. Hardwood plywood grades. The Hardwood Plywood Institute uses a numbering system for grades and faces of back panels. A grading specification of 1 or 2 would indicate good face with grain, carefully matched, and a good back but without grain, carefully matched. Number 3 would permit noticeable defects and patching but would be generally sound. A special or premium grade hardwood known as architectural or sequenced matched. This usually requires an order to a plywood mill for a series of matched plywood panels. For either softwood or hardwood plywood, it is common practice to designate the grade by a symbol. G2S means good 2 sides, G1S means good 1 side. In addition, the various types of grades of hardwood plywood is made with different core construction. The 2 most common are the Veneer Core and the Lumber Core. Veneer Core are the least expensive, fairly stable and warp resistant. Lumber cores are easier to cut, the edges are better for shaping and finishing, and they hold nails and screws better. Plywood is also manufactured with a particle board core. It is made by gluing veneers directly to a particle board surface. Next section, composite board. Panels made up of a core of reconstituted wood with a thin veneer on either side are called composite board or composite panels. These materials are widely used in modern construction. They are good as sheathing, subflooring, siding, and interior wall surfaces. In cabinet work, hardboard and particle board serve as appropriate materials for drawer bottoms and concealed panels in cases, cabinets, and chests. They are manufactured by many different companies and sold under various trade names. Hardboard. Hardboard is made of refined wood fibers pressed together to form a hard, dense material, 50 to 80 pounds per cubic foot of pressure. There are 2 types, standard and tempered. Tempered hardboard is impregnated or filled with oils and resins. These materials make it harder, slightly heavier, and water resistant, and darker in appearance. Hardboard is manufactured with 1 side smooth. That's noted as 1S1, S1S, excuse me, or both sides smooth, S2S. It's available in thicknesses from 1/12 of an inch to 5/16. The most common thicknesses are 1/8, 3/16, 1/4. Panels are 4 foot wide and come in standard lengths of 8 foot, 10 foot, 12 foot, and 16 foot. Particle board. Particle board is made of wood flake chips shavings that are bonded together with resins or adhesives. It is not as heavy as hardboard, 40 pounds per cubic foot. It is available in thicker panels. Particle board may be constructed of layers making different size of different size wood particles. Large ones in the center provide strength. Fine ones at the surface provide smoothness. Particle board is used as a base for veneers and laminates. It is important in the construction of countertops, cabinets, drawers, and shelving, many types of folding and sliding doors, room dividers, and a variety of built-ins. What they mean is built-in cabinetry, furniture that is actually connected to the walls and corners of the house. It is popular because it has a smooth grain-free surface and is stable. Its surface qualities make it a popular choice as a base for laminates. Particle board does not warp and requires little adjustment after installation. Particle board is available in thicknesses ranging from 1/4 to 7/16. The most common panel size is 4 foot by 8 foot. Wafer board is produced from high quality flakes of wood that are about 1.5 inch square. These flakes are bonded together under heat and pressure with phenolic resin, a waterproof adhesive. Both sides of wafer board have the same textured surface. This surface has a natural slickness that can be minimized by special treatments. The density of wafer board is about 40 pounds per cubic foot. Standard panel size is 4 foot by 8 foot, and thicknesses range from 1/4 inch to 1 1/8 inches thick. Oriented strand board. Somewhat like wafer board in appearance, oriented strand board is also made up of wood fibers adhered to each other with suitable resins and glues. The fibers are put down in successive layers arranged at right angles to one another. A relatively new product, oriented strand board, or OSB, is approved by all model building codes in the United States and Canada. Its applications are many. A combination of some floor and underlayment is one of them. Second, sheathing for exterior walls. Oriented strand board provides an excellent nailing base for siding. The large size of the panels also reduce air infiltration through the building's walls. Finally, APA rated siding. When special surface treatments are used, oriented strand board is suitable as an exterior finish. Wood treatments, next section. Wood and wood products that will be exposed to high levels of moisture should be protected from attack by fungi, insects, and borers. Millwork plants employ extensive treatment processes in the manufacturing of such items as door frames and window units. Structures that are continually exposed to weather outside, stairs, fences, decks, and furniture should be fabricated from pressure-treated lumber that has long-lasting resistance to termites and fungal decay. I'm going to pause there. The pressure-treated lumber that we made at scale for the scale model house project, we either painted green or red. Those are generally the colors that you will get the pressure-treated lumber in. In addition, the lumber should be pressure-treated with liquid repellent that slows the rate at which moisture is absorbed and released. The Environmental Protection Agency has produced a consumer information sheet that outlines uses and handling precautions for treated wood products. Copies of the sheets are available at home centers and lumber outlets. Treated wood should only be used where protection against decay and insects is important. Treated wood should never be used where the waterborne arsenical preservative in the treatment may become a component of food, animal feed, or drinking water. Arsenical, it refers to arsenic. So this is heavily toxic. And just another note about pressure-treated lumber. It should never be used in the interior of a wall of a house. So for an interior room, you should never be using it. It's so toxic that you will will or you may experience health problems because of its toxicity. So remember, keep this on the exterior of the house. This is usually something that's touching the foundation or something to do with the deck or exterior beams. When wood is treated under pressure and with controlled conditions, the treatment penetrates deeply into the wood's cellular structure. Thus, treated wood resists rot, decay, and termites. Even when exposed to severe conditions, the wood provides excellent service. There are three major types of liquid preservatives. The first, waterborne, which are used for residential, commercial, recreational, marine, agricultural, and industrial applications. Of the waterborne preservatives, chlorinated copper arsenate, CCA, acid copper chromate, ACC, and chromated zinc chloride, CZC, are used. Waterborne treatments leave the wood clear, odorless, and paintable. Next, oil-borne. Oil-borne, the best known oil-borne preservative is chlorophenol, which can be mixed with various solvents. It is highly toxic to insects and fungi. However, treated wood may become discolored. It is used on farms, around utility poles, and in industry. Third, creosote. This is a mixture of creosote, coal tar, and heavy oil. It is suitable for treatment of pilings, utility poles, and railroad ties. Creosote wood cannot be painted. The creosote is very pungent. You will definitely be able to smell it, and it has a dark color to it that really stands off of the wood's grain. Often treated lumber carries an identifying end tag or stamp. This stamp indicates the type of preservative, proper exposure conditions, and other information. More information on treated lumber can be found by contacting the American Woods Preservatives Bureau, P.O. Box 5283, Springfield, Virginia, 22150, zip code. The final thing I'd like to say about pressure-treated lumber is once you cut the end of a pressure-treated lumber, you're going to also need to seal it with an appropriate sealant. The end, once you cut it off, you can see the coloration. The coloration of it once you cut into it, you can see it. It goes kind of like this. And so all of this area is saturated with its preservative, but this middle area is actually not, since it was inside the center of the board when it was pressure treated, it does not have any of the protective chemicals, so we must brush a chemical preservative. Many people choose copper green, and so you would just paint it with the brush on the end, let it soak, paint it again, let the wood really draw it in the center section. This center section would look like the normal wood, and then this other section would have a different color. Handling and storing, next section. Building materials are expensive and should be maintained in the best conditions practical. After they are delivered to the construction site, this becomes the responsibility of the carpenter. Piles of framing lumber and sheathing should be laid on level skids raised at least 6 inches above the ground. Be sure all pieces are supported and lying straight. The reason we want it 6 inches off of the ground is you need the air circulation around it. Cover the materials with a canvas or waterproof paper. Polyethylene film also provides a watertight covering. If moisture absorption is likely, cut steel banding on panel materials to prevent edge damage when fibers expand. Keep coverings open and away from the sides and bottom of the lumber stack to promote good ventilation. Tight coverings promote mold growth. You absolutely do not want mold on your lumber. The mold just propagates in your building process, and you'll have to go through a separate process of mold abatement, meaning that you'll have to bleach the mold, or you'll have to neutralize the mold. Once it's dead, then you can continue with your construction project. So it would be a lot better to not have mold in the first place than to have to clean up the mold by trying to cut corners and not cover your material. Exterior finish materials, door frames, and window units should not be delivered until the structure is partially enclosed and the roof surfaced. In cold weather, the entire structure should be enclosed and heated before interior finish and cabinet work are delivered and stored. APA structural wood panels delivered on site should be properly stored and handled. Protect ends and edges from damage whenever possible. Store panels under a cover. Keep sanded panels and other appearance grades away from high traffic areas. Weigh down the top panel to prevent warpage. Cut the steel band on bundles if rain or heavy moisture is expected. Panels stored outdoors should be stacked on a level surface atop 4x4 stringers or other blocking. Use at least 3 stringers. Never allow panels to touch the ground. Keep panels well ventilated with stickers to prevent mildew growth. When finished lumber is received at a different moisture content than it will attain in the structure, it should be open stacked with wood strips so that air can circulate around each piece. Plywood especially, the fine hardwoods, must be handled with care. Sanded faces become soiled and scarred if not protected. While stored, panels should lie flat. Next section, engineered lumber. Builders have relied on traditional wood products for residential and light commercial framing.